In this video, we will continue to practice solving triangles using the law of sines when we are given the infamous ambiguous case, when we're given side-side angle. It's called the ambiguous case because given two sides and the non-included angle, a number of things could happen. There could be no triangles at all formed by this information, or and that's when this side right here is too short. When the swing side is just the right length, you will get one right triangle. If the swing side is bigger than the rigid side, you will get one triangle like this. But finally, if the swing side is longer than the height, yet smaller than the rigid side, then you can form two triangles. Because we don't know what the situation is until after we do some calculations, we call this the ambiguous case. Now, problem number 5. Right away we see that we are given one angle and two sides. Anytime you see that you have two sides and an angle, you should go ahead and put the angle in the lower left corner of your diagram. So draw yourself a triangle and put the angle right here. Now, because this could be the ambiguous case, you should go ahead and lightly sketch your swing side. We don't know exactly how this will go. And then we'll have the rigid side. But this is angle B, which makes this side B automatically. So this must be the 38 over here. The other side, go ahead and put it as the rigid side. Let the other side be the rigid side. So the 16 will go here. Now if that is A, then that makes this angle A over here. And if this is A and B, that makes this angle C up there. Now we see that we do in fact have a side-side angle situation. This is the ambiguous case. So to figure out if we can even make a triangle at all, we need to find the height right here. So let's imagine that this height, let's call it h. We can calculate the height using the sine function. The sine of 117 is equal to opposite over hypotenuse. So that's going to equal h over 16. If I multiply both sides by 16, I will have 16 sine 117 is equal to the height. Now I'm going to go ahead and put this in my calculator. And I am getting 14.256. Okay, so the height we just found is 14.256. I'm going to go ahead and just put 14.3 temporarily. Can we make a triangle? The only point of this is to see if this swing side is long enough to reach the ground. And yeah, 38 is longer than 14.3, so this is long enough to reach the ground, so we can definitely make at least one triangle. The question is, can we make two triangles? Well, I think not, because my swing side, hold on, let me free this, ungroup my swing side. If you look at the swing side here, it's 38. So it makes two triangles when you can swing it and it could hit here, then it swings and it could also hit here. Now, does it make sense that it could hit here? Not if it's 38, right? Because this side right here is only 16. So you can't have a side length of 38 inside a triangle that has a side of 16. It would have to be shorter than 16. So there's no triangle that can be made inside like this. So we can make a triangle, but only one triangle, this one. Okay, so that's all we really needed the 14.3 for, so I'm just going to erase that now. In fact, we don't even need this anymore. Okay, so now let's just go on and solve this one triangle. So, my friends, what do we need? We are missing the measure of angle A, so we're going to need that. We're missing the measure of angle C, so we are going to need that. And we are missing side C, so we're going to need that. So these are the three values that we need to find to solve the triangle. Notice that we are given this angle and the opposite side. So we can begin to use the law of sines by doing the sine of 117 over 38. Alright, the sine of the angle divided by the side. Now that should be the same ratio no matter which angle and opposite side you pick. But I see I've got this 16, which is a side, and the opposite angle is angle A. So I can just go ahead and say the sine of angle A. Now, if I want to get angle A by itself, well, the sine of angle A, I would multiply both sides by 16. So that's going to cancel out the 16s and just leave me with the sine of A by itself. Now, if you have the sine of an angle and you want just the angle, you're going to need the inverse sine to do that. So I'm just going to go ahead and write the inverse sine. So the inverse sine of all of this, okay, so 16 sine 117 over 38. The inverse sine of all of that is A, because inverse sine is the angle whose sine is this, and that's exactly what we're looking for. So I'm just going to put this in my calculator. Alright, so inverse sine, and I'll need a fraction now. And then I've got 16 sine 117 over 38. Alright, so that is 22.034. So that's the measure of angle A. Now we could easily find the measure of angle C by subtracting both of these from 180. And I'm getting 40.966. Notice how I am using 3 decimal places. You should do the same. Now we need to find side C, and we will do law of sines once again. I'm going to again use the same ratio that we started out with. Sine of 117 over 38 equals. But now I'm going to do this. I've got this angle and the opposite side. So I will do the sine of 40.966 over C. If I cross multiply, I'm going to get C sine 117 is equal to 38 sine 40.966. Now to get C by itself, I need to divide both sides by the sine of 117. So the sine of 117 will cancel out. That will leave C by itself. So now I just need to type all of this into my calculator. Okay, 38 sine 40.966. Over sine 117. Oh no. That's better. Boom. I'm getting 27.961. Got to round up. You know what? I really wanted to use pink. And that's it. We have solved the triangle. Okay, let's move on and do problem number 6. Again, we are given two sides and an angle. So we need to see if this is going to be the ambiguous case or not. If I have one angle, I'm definitely going to put it here in the lower left-hand corner. Okay, and so this will be angle B, which means this over here would be side B. That's 9. I'm leaving this dotted because this is my swing side. We don't know for a fact that it even will reach the ground. We will let the rigid side be the other side. So this will be 18. And this is side A, which means this is angle A across from it, which means this is angle C. And now we see that we have side-side angle. This is the ambiguous case. Side-side angle. Okay, so at the moment we do not know if this will make a triangle at all. So we have to figure out what is the height of the triangle. That way we can see if this swing side is long enough to even reach. So let's call this height h for a moment. We can calculate what h is in the following way. If we do the sine of 84, that's opposite over hypotenuse. That would be h over 18. If I multiply both sides by 18, I'm going to get 18 sine 84 is equal to h. I'm getting 17.901. The question is, will we be able to make a triangle? Well, let's see if I can grab this. Okay, if this side is 9, the swing side, and the height of the triangle is 17.9, then this side is going to be way too short to reach. It's about half the length. 17.9 is about 18. That's twice as long as this side. So there's no way that this side is going to reach. There's no way this is going to make a triangle. So we can just go ahead and say no solution.